From breakthrough devices to the bottom line, we explore the investment trends, the commercial models, and the strategic thinking required to bring neurotechnology to the global market. This is the business of Neurotech. Hello, everybody, and welcome to the show. I'm your host, Adam Fraser, and today I'm joined by Derrick Buchanan, adjunct professor at Stanford and a clinical neuroscientist in its brain stimulation lab, where he uses brain imaging to personalize magnetic stimulation for treatment-resistant depression. He also works in the Stanford Psychedelic and Conscious Lab, where he studies psychedelic journeys for rapid healing. And amongst other things, he's an author, and a TED Talk speaker, and an entrepreneur. Many things to talk about. Derrick, a very big welcome to the show.
Thanks so much, Adam. Yeah, I really appreciate the invitation. Love what you're doing here, and I'm glad to be on. Happy to chat with the audience.
Yeah, now look, with every guest I've had, there's always a challenge of there's multiple topics I could talk about. Which ones am I going to hone in on? With you, Derrick, there was such a breadth of directions we could go, given your academic, research, TMS, Stanford, entrepreneurship, your own startup. So I had to filter to make this sort of semi-digestible for the audience. I think if we'll run through life at Stanford and particularly spinning out startups and IP from Stanford, and then TMS, you obviously have a deep subject matter expertise in. It's come up a lot on the podcast sort of in passing. So I think it'll be very useful for the audience to get a bit of a deep dive into TMS. And then if we've got time, we'll have a broader chat about the neurotech landscape, BCI, neuromodulation, and so forth. So lots to get through. Why don't we get into it, Derrick? And you hail from Canada. You're now based in Stanford. Talk us about the journey in between, your backstory today.
Yeah, I would love to go through it. Hopefully, I'll do my best to give you the short highlights. Correct, I did come from Canada. I grew up in a town called Oshawa. It's not far from Toronto, where we have a really robust TMS and brain stimulation program, actually, in Toronto, that is. And I spent 11 years in Ottawa. That's Canada's capital, where our parliament is. And that's where I did my undergraduate and graduate school, my PhD in clinical neuroscience. Largely, that was also in collaboration at the Children's Hospital of Eastern Ontario. A lot of people may not have heard of CHEO. That's the Children's Hospital of Eastern Ontario. Many people are familiar with Sick Kids in Toronto. It's one of the top children's pediatric hospitals in the world. And CHEO is sort of like the capital Sick Kids. So we work a lot with children's mental health. I was in the pediatric neuropsychiatry unit, which is where most of my PhD work was done. And that's when a lot of this started for me, was about 14 years ago, back in 2012. So I've been doing precision brain stimulation, brain imaging for about that long. Started out as a humble research assistant, volunteering in a lab in what was called the NICER lab, the Neuroscience of Imagination, Cognition, Emotion Research Lab, doing a little bit more cognitive neuroscience. Then got really more interested in clinical neuroscience when I came out of my undergraduate to do brain stimulation work and working in neuropsychiatry and that sort of intersection. I juggled a few titles all at the same time through graduate school. So I was cross-appointed over at the hospital, working in neuropsychiatry with kids as young as 6 years old. I ran some of the first and earliest brain stimulation trials in young children using transcranial direct current stimulation. We did safety, tolerability, acceptability trials. So at that point, we weren't even yet focused on efficacy. We were just asking, is it safe? Can we do TDCS in children? And pairing that with things like EEG. At the same time, during graduate school, I was teaching at my old university, teaching neuropsychiatry, introduction and advanced research in neuropsychiatry, clinical neuroscience courses. I was kind of the first person to ever bring this sort of human and clinical neuroscience to my university, is Carleton University in Ottawa, and would teach brain-computer interface courses on neuroscience of consciousness and creativity, just a lot of really fun, exciting courses. I love that. I do miss teaching a bit. I've been on 100% research time for the last 5 years, and research/business. So that's, there was some transition there. And I also served as a director of research at a private medical clinic called the Seeker Center for Integrative Medicine, which was a integrative healing practice that really focused on combining many different healing techniques, including brain stimulation, neurofeedback. We had an EEG and a brain injury clinic there. We mostly treated chronic pain and brain injuries. And I managed that clinic as well for about 5 years and built up a research program there. So I have that kind of background on TBI work outside of psychiatry as well. Then in 2019, started my first company called Canada Neuro. It was very patriotically branded, I guess, at the time. The vision there was really to have this global or, ultimately nationwide program that was kind of extended from the work I was doing at the Seeker Center to help people with brain injuries, collecting baseline brain imaging across populations that were susceptible to brain injury. So this was a program I developed that I coined and trademarked called Neurosurance, which was like insurance for your brain. And I'm now working on kind of developing that more through one of my current companies out in Canada. We also kind of did a small rebrand with Canada Neuro when I came to the US. I called it Baseline Neuro because it was based on this problem that when we want to help people correct their brains after a brain injury, we're often comparing that to a normative database as opposed to their own brain. So the thesis was we need to get brain images before these patients get the brain injury. And so we were doing that pre-deployment and pre-season. So at the beginning of a season for athletes, like people who play football or hockey or maybe susceptible to brain injury. Then 2021 came out to Stanford. I took a role as a postdoctoral fellow. It was a big jump. It was a tough decision because I had just started this company up in 2019. COVID started like 6 months later, kind of put a real damper into that. And then I was teaching. Then I was decided, okay, I was either going to go full time and try to run the company, but if I had a really good postdoctoral opportunity, I would have to take that. And I couldn't have imagined a better opportunity to come work with Nolan Williams, who was my mentor and friend of mine for, since that time. So he hired me to come out to Stanford in 2021, worked on some of the largest brain stimulation trials that we have ever seen in collaboration a lot with Weill Cornell Medicine in Manhattan with Connor Liston's team. And we had a large trial. It was a little over $6 million trial funded by the NIMH to do hundreds of subjects. So I led that trial while also contributing to several other of our clinical trials that we had at the Brain Stimulation Lab, doing fMRI guided TMS treatments or ITBS treatments. So I had that's where I built a lot of that acumen and was trying to transition from this electrical stimulation and electrical brain imaging that I'd done during my PhD to now doing more magnetic brain imaging and magnetic stimulation. So that was the initial reason I was hired. I came out on a CIHR, which is Canada's like NIMH. It's the Canadian Institute for Health Research. So I won a 3-year fellowship from them to go to Stanford to do that. And then continued that work. It was a 5-year-long trial. So we actually just enrolled our last participant in December 2025 and are working on analyses and things throughout the summer. And so that was a long go. And Great. Finally, in the last 2 years, I started in parallel working on a couple things, which is kind of where the business endeavors came in. We won a series of grants through Stanford. And I think that's one of the things you want to talk about is sort of the Stanford ecosystem and how they support entrepreneurs and scientists in that translation. And so we won close to $500,000 of grants across several different awards. The Stanford Neurotranslate Award, the Coulter Neuroscience Award, the Stanford High Impact Technology Award, and the Stanford Neuroscience and Human AI Award. It's 4 different awards, each of them valued, a little over $100,000. And that is what helped us build the prototypes for initial products for what is now the company that I'm largely focused on. And I also have some other side companies and things I've been working on in the last couple of years.
Derrick, for those on YouTube, you don't look old enough to have jammed in the amount of experience you just described. That is a deep and rich history across neuroscience, neuromodulation, TMS specifically. So a lot to unpack. Great backstory, like a few threads to pull on as we get into the different topics. But look, we'll get to TMS shortly, but let's talk a bit about Stanford. I'll link in the show notes. Lucky enough, you're the second adjunct professor from Stanford I've had on. David Eagleman was episode 6, and similarly, academic, researcher, also TED talker. and also an entrepreneur. So he's lived the experience of taking ideas developed inside the Stanford ecosystem into the market. But yeah, just give a bit more depth on Stanford is truly kind of world renowned. Its proximity to Silicon Valley, clearly not a coincidence, obviously, historically. Why has Stanford become, so globally well known in this field and in this area?
Yeah, first of all, love David. He's fantastic. He's taught me a lot and been helpful along my journey of trying to become a better speaker and work in that scene. And just listened to his episode recently as well. I'd encourage folks to go check that one out if you haven't already. I still learn a lot every time I listen to him speak, so I love hearing that. Stanford, I think the proximity is a huge piece. Like, I think where I grew up, it wasn't like Toronto is in a place in Canada where dreams can come true and things can happen. Where I grew up in Oshawa, dreams can come true, but it doesn't seem as realistic, I guess. Like, you don't necessarily think, oh, maybe one day I'll own a company that's worth, a multi-million-dollar company. But you come to Stanford and it seems a lot more feasible. It just seems plausible. You come here, you meet people, you have conversations with people, and it's like casual that, yeah, I do this, I do that. And it's like the people you meet are remarkable. And even when I meet with students at Stanford, I can meet somebody and it's like, not only are they at Stanford, they're a top student, have straight A's in their class, but they've also done something like, yeah, I also, I have a silver medal in swimming and then in the Olympics. And then I fly planes as a hobby and I actually flew halfway around the world. Like, it's just this incredible place that people flock to. I think historically, sometimes we think about Stanford, there's always been these times in history, like where people would go to Greece and Rome and where all of these smart people would come together because they knew this was this hub, and Stanford does that. And Stanford is a inspiration, I think, for a lot of people, and they really just help facilitate and support the translation of research and good research by putting a ton of money into those, by having a lot of internal competitions, which is a slightly lower barrier than having to win these large external grants. Now, we do bring in a lot of money from external grants, from donors, from philanthropists, but there's a lot of money inside Stanford to help support good ideas and business propositions.
I mean, it's become very it's the classic example, a couple of young postdoctorates with some really cool research, some great IP, Y Combinator or some other seed fund will take an early check. I think people know at a high level that this happens, but, maybe give a little bit more detail mechanically for people that aren't familiar with IP, tech transfer offices. How does this work? Like, what's the kind of royalty share? As much as it's a very idealistic, romantic, you can, to your point, live your dream, there are some, detailed commercial discussions that have to happen around IP sharing and royalties and so forth. So maybe just give a bit more color on how that all works.
From what I've learned in the last couple of years, Stanford, and maybe I'm biased on this, but I've talked to people from MIT, from Harvard, from Europe, like EPFL, like from all over. And it sounds like Stanford just has one of the most robust tech transfer offices in terms of the system that they built. And a lot of other universities try to model themselves after Stanford. We also have programs like Biodesign and the High Impact Technology Fund, which is actually like a subsidiary part of Stanford's OTL, or Stanford's Office of Technology and Licensing, where they give money and they really help researchers learn this whole process. So there's so much education, workshops, pedagogy around how to do it, which I think is not the case at other universities. And that's one of the strengths, I think, of OTL, Stanford's Office of Technology and Licensing. And we spin out so many groups and different companies through that. So it is true that at Stanford, when you come here, you basically sign over the rights to all of your IP, to anything that you discover. But that doesn't leave you SOL. I know it sounds kind of tough from the beginning, but the way that people end up making money and end up flourishing through that still is by forming startups and forming companies. So when you come to Stanford, if you're a professor, if you're a postdoc, it's different if you're a student, actually. I don't know 100% exactly how it works, but if you're a student and you invent something at Stanford, my understanding is that you actually do retain the majority, if not all, of your IP. If you're there as, say, a PhD or as a undergraduate student, but as a postdoc or at the faculty level, you do sign over the rights to your IP. And it's does not sound like a very favorable split. Stanford owns roughly 75% of that, and the inventors own about 25%. So that's the initial split on that IP. Now, if nothing ever happens to it, then it doesn't really matter how much anybody owns. What happens next is that technology has to get translated or licensed out to a company. So sometimes OTL will license that to a large company, maybe pick a pharmaceutical company or a large med tech company, and they can license it. But more often than not, what ends up happening is that the inventors will form a startup. They will license or typically get a exclusive license for their own technology to the company. So now they can commercialize that. And then you retain 100% ownership of your company, which manages the license for that. Stanford will sometimes take a small percentage of the company in that licensing negotiation. Sometimes they'll take some royalties, and they'll usually take a licensing fee. So that's how they get their buck. But then that helps the researchers translate what they're doing into the real world. And typically Stanford will also invest in their companies after when they do a Series A or a price round. Stanford will often buy in and put in money and buy shares as well.
Great. No, very helpful explanation. I mean, the flywheel well and truly spinning at pace. It becomes almost self-fulfilling at this point that the brightest minds will just be attracted to Stanford, especially if they've got a kind of entrepreneurial itch and they suspect that some of the research they want to do could ultimately be valuable in the real world.
Exactly. Yeah, I think that was one of my rationale for coming to Stanford. I knew that I was going to come here and have sort of the dream postdoctoral experience. I got to, if I were to write down everything I was looking for in a postdoc, it had that and more. And you're in California. It was a real win all around. And I knew I would get to come here and learn about entrepreneurship at the same time, not just from Stanford. Like if your PI has never done anything entrepreneurial, there's a million resources at Stanford to help you figure that out. I had the benefit of working with Dr. Williams, who had done entrepreneurial things, and in the last 5 years had started about 5 companies, and I'm the 5th company that spun out of the Stanford Brain Stimulation Lab in just 5 years, and now those 5 companies cumulatively are worth over $1 billion.
Amazing. Great stuff, Derrick. Look, let's shift gears. Let's get into transcranial magnetic stimulation. As I mentioned in the intro, 10 plus episodes in, it has come up a number of times. I work in the field at Omnition. I'm very now familiar with TMS, but I don't want to assume any listener has a deep knowledge of the field. So maybe just ease us in to give us kind of TMS 101, a bit about its history, how it works, its efficacy, and what the research shows.
So I'll start with TMS, transcranial magnetic stimulation, and making people aware that is a big umbrella. There's many forms of TMS. So you might hear terms like RTMS, repetitive transcranial magnetic stimulation, ITBS, which is intermittent theta burst stimulation, CTMS, continuous transcranial magnetic stimulation. So a lot of different forms of TMS, and they're typically named based on the types of parameters that they're describing. So TMS is the delivery of magnetic pulses into the brain. So it's typically done using a pulse generator power supplied machine, which then connects to a coil. That coil is often arranged in a circle or a figure of 8 manner. So when you pass an electric current through those shaped coils, it produces a magnetic field at the center of that. And when you place that over the head, it can produce magnetic pulses that interact with neurons or brain cells that change the polarity of those neurons in order to make them fire. That's what makes TMS a brain stimulation tool, which is sometimes contrasted with a neuromodulation tool, such as TDCS, where transcranial direct current stimulation is an electrical form of stimulation that doesn't actually cause action potentials. It doesn't make neurons fire, but it can increase the likelihood of neurons firing or decrease the likelihood by affecting sort of the potentiation across the membrane, but it doesn't cause them to fire. Whereas TMS literally changes the polarity of a neurons, causes them to fire. And it's the repeated stimulation that leads to those long-term plasticity changes and the efficacy that we see that's actually able to strengthen or help restore brain regions that have become hypoactive or help to turn down activity of brain regions that are hyperactive. So kind of the broad way, and I'm giving broad strokes here, but almost any mental health or neurological condition can be described by some area of the brain not being active enough or some area of the brain being too active. So you got hyperactivity, hypoactivity, and sometimes it's about how those areas are communicating or failing to communicate with each other. So we can use TMS to modulate that activity non-invasively, meaning we don't need surgery. I could set one up in the room you're in right now, and it's totally safe. It's a really easy technique to use in that way, and we can modulate brain activity. The little bit of history there. So the first approval for TMS came in 2008. So it's been around for a while, but it's still sort of I constantly have to remind myself that a lot of people have never heard of it. And people listening to this podcast probably have, but the reality is most people I talk to, and a lot of patients still have not heard of it, or maybe they vaguely heard a term, but they don't really know what it is. So 2008, first approval came through for depression. I'm going to skip a whole bunch of steps and go to 2018. It used to take 37 and a half minutes to do one session of TMS. And a typical course of TMS was somewhere between 20 to 40 sessions. And often people would do 30 or 36 is kind of one of the standards. That's what got approved by a lot of insurance companies. That was the initial. So you come in every single day for 5 to 6 weeks, typically with weekends off, and you're doing 37 and a half minutes session. That was using what we called 10 hertz TMS. Then in 2018, again, skipping a bunch of steps there, Dr. Jonathan Downer's group and Daniel Bloomberger out in Toronto, they ran what was known as the 3D trial, which is what it was a non-inferiority trial that led to the FDA clearance of intermittent theta burst stimulation, which is a newer version of TMS that only takes 3 minutes, and it uses pulse in this theta burst pattern. So this isn't exactly correct, but the way I typically describe this when I'm telling patients or general public is we kind of found a way to deliver pulses in like this faster way that allows us to condense the session from 37 and a half minutes to 3 minutes, which was something Jonathan was really passionate about because of scalability. Like now you can see 10 times more people in that time span because you only need a 3-minute session per day. So it's still once a day for 6 weeks. That turned out to be non-inferior to the 10 hertz method, which led to the FDA clearance. There's 200 people in the 10 hertz group, 200 in the ITBS group. I think it was actually like 204, 203, something like that, but roughly a large trial, took a long time. Then fast forward a few more years, come to Stanford, and Dr. Williams had this idea that, TMS was significantly underdosed so that we could increase the dosing of TMS and condense that using what we now call AITBS, which is an accelerated ITBS protocol. So in a single theta burst session, that's usually 600 pulses, a 3-minute session, we did that as a 10-minute session, delivering 1,800 pulses 10 times a day. So we condensed a 6-week protocol to 1 day and delivered the equivalent of that, so 18,000 pulses in 1 day or 90,000 pulses over 5 days. So a full course of TMS in a 5-day period. And then that was FDA cleared with breakthrough status in 2022 and has been developed into what's now called SAINT, or the Stanford Accelerated Intelligent Neuromodulation Protocol, which also pairs the TMS with an fMRI guided approach. So the 2008 version of TMS literally measured the brain with a tape measure. You take a tape measure, you approximate some points on the head. The Jonathan Downer trial, if I recall correctly, used what we call structural MRI. So that was guided by an MRI, which is like a picture of the brain, versus Stanford or SAINT, the SAINT model, which is guided by an fMRI, which is a functional, more like a video of brain activity. And that led to those earlier trials, like the 10 hertz trial in 2008, about 30% of people go into remission, about 50% respond to TMS. Using SAINT, we typically see around 80% of people remitting from depression, treatment-resistant depression, patients who've tried medication therapy and all this, going into remission in an average of 2.6 days. So days, not months or years or weeks, just days, and they're in remission. So that's kind of my little evolution and arc of how I see TMS.
That's a great summary. Bookmark this podcast if ever you want a refresher on TMS. No, really excellent summary, Derrick, and I'm sure obviously there's a ton of detail in between. Maybe we can link some resources in the show notes for people that want to dive deeper into TMS. But zooming out, you touched on the high points there. Back to kind of the Stanford analogy. If I was an MBA, mythical hypothetical case study, and I described an addressable market. 1 in 5 Americans have a mental health disorder in any year. As Mariam from Brainified on episode 4 said, over 1 billion people around the world have some form of mental health disorder. I've got a solution with minimal side effects and tremendous efficacy, within reach, with some reimbursement funding. And I say to myself, why hasn't this taken off more than it has? To your point, why when I meet people, I call them normals that don't work in Neurotech, people have not even heard of TMS, let alone explored it. So what do you think is holding the sector back?
It's a great question. I think there's a lot of reasons to understand or think about why that might be the case. Some of that I might say is just awareness. It could be as simple as the fact that a lot of people still don't know about it. I think the question of like what's holding us back, or why have a lot of these companies remained unprofitable, like the large TMS companies. I think a lot of the clinics are quite profitable. The clinics that deliver TMS are quite profitable. It's the TMS manufacturers that have remained struggling, I think, over the years in terms of who's actually building TMS and offering TMS. But the clinics typically have long waiting lists. They have a lot of interest because even just among the patients that they can see, and they don't have a super hard time billing. But I have heard from and learned from setting up multiple clinics, including clinics over at Stanford, that each new clinic or each new instance of delivering TMS does often require those clinics to liaise with those different insurers or those payers, even if that payer already reimburses another clinic and they regularly do this and they already are aware of it. But if you're a new clinic, now you have to liaise with them and kind of fight through that battle of administrative tape to get them on board. So a lot of clinics, I think, maybe would benefit from having somebody who's well experienced on the insurance side and just spending days or, kind of a full-time person just constantly liaising with them to make sure that these patients are getting those reimbursements. And maybe that's a gap that's not always being filled. One of the things, I have a company now called Heal Now Technologies, and part of that is we're trying to fill this gap with rapid acting treatments. We've developed a portable transcranial magnetic stimulation device that's less than 20 pounds and less than 1 cubic foot in size. So one of our thesis of this company is we want to help people get better. We want to help them get better fast, and we want to scale TMS. Our mission is to at least double the access to TMS in the next 5 years. And I think we can do better than that still, but I think that's a reasonable goal. There's only it's not a hard number because it's not easy to get the number, but something like 2,500 to 3,000 TMS devices deployed across the entire United States. So if those devices, and these are US numbers, I think there's roughly 2,000 to 3,000 across all of Europe as well. Compared to China, for example, China has way better coverage on TMS in terms of access than we have here. In the US or in Europe already. So they're way ahead of us, even though we might invent the technology and get the clearances, but then they go and manufacture much faster and they get devices deployed. So I think one of the challenges here is we need more patients to know about it. We need it to be taught in medical school and to psychiatrists and psychiatry residency. At Stanford, we have an interventional psychiatry program. We take one fellow a year. One fellow for all of interventional psychiatry per year. It's just there's an insufficiency in the training, but I think there's now a lot of interest, and it's hard to set up a TMS clinic at the moment, which is one of the problems my company's trying to solve by having a more portable solution. Because right now, if you set up a TMS clinic, it can take months, typically 6 months or more is what I see for most people trying to just get a clinic off the ground. Whereas we want to be able to send you a device and tomorrow you could just plug it in and you're ready to start offering TMS. Now you might have to still work through the insurance and figure out the billing and so on. But to have it as a tool that any doctor or any psychiatrist could just have on their shelf, as opposed to a dedicated room, a dedicated clinic where you have to rewire all the electrical. Most TMS devices don't plug into wall outlets. They need special charging stations and all these little complications that we've attempted to solve. And so it's hard to open 10,000 TMS clinics, but I think we could place 10,000 devices in doctors' offices all around the country, and that would help more people have access. And I think that's kind of a success model. I think a lot of the TMS companies, manufacturers are still stuck in this old model, but the clinics themselves are not having trouble making money. They're doing great. So I think more clinics, more doctors would be highly incentivized to offer TMS if it was just easier to do so.
Great summary. Last question, Derrick, on TMS. So it's great to sort of understand the history and think about the friction points, what's holding kind of the macro sector back. So 30 plus sessions, there's obviously a friction point. I have to drive to a clinic 30 days in a row. I've got a job. That's problem one. It seems like with the Saint protocol and other things, we're certainly squeezing that. There's the size of the hardware, the cost, the accessibility to the hardware. Again, people like yourself here and now with Heal Now looking at that. Ultimately, do you see this evolving into a kind of wearable at home? The ultimate minimal friction is direct to consumer with some sort of cap I can wear or some sort of wearable device. Is that, do you think, where TMS is going in the medium term?
I would say not in the medium term. Medium to long term, I think it's going to be a bit of a long road before TMS could be offered at home. We get that question a lot because when I say portable TMS, a lot of people assume we're going after at home. That's certainly in our roadmap, but it's not the first thing we're going to be able to do. Like, first thing we're going to do is just help other TMS clinics expand and help other doctors be able to offer TMS as a solution. But at home is probably an end holy grail, or more on the training side, as we get more evidence for not just healing illness, but promoting wellness. There's so much interest in TMS for cognitive enhancement, memory enhancement, general wellness. And there's so many indications for TMS. Most of my work is focused on depression, but TMS has been FDA cleared for OCD, for migraine, for, I believe, anxiety, and if not, very soon for treating chronic pain, for post-stroke recovery, surgical mapping. Like, there's a long list, and the list will continue to grow. And there's a lot of people who would benefit from, being able to have that at home and have it be a little bit easier to use and be more accessible, in the same way that we had 2 clearances this year for TDCS with Flow, and there's a second company I can't recall at the moment, but just 2 in the last, say, like 12 months or so that were cleared for TDCS at home. Now, TDCS is a slightly lower risk profile, I think, than TMS. If used incorrectly, TMS, you could modulate brain activity that you don't want to be modulating. I think there's definitely ways to develop an at-home protocol. And there's spa type places, concierge type places, gyms, all these places that are interested in maybe offering TMS. And there's a lot of those things that we're considering as a company as possible distribution and outlets. But to get TMS approved in an at-home capacity will require, pretty extensive clinical trial data. Not exactly clear on what the FDA would want to see for that and how it would be correctly safeguarded. But I can envision ways that would be done. And, we're excited to do that in our medium to long term, but I don't think it's something that's coming in the next few years.
Got it. Look, we could talk about TMS for hours, but given someone of your experience on the podcast, I want to just shift gears and finish maybe with a broader assessment of the neurotech landscape, kind of zoom out to the strategic level. Always like to ask guests, Derrick, and everyone describes it slightly differently. When you hear the phrase neurotech, or you think about the addressable market for neurotech, how do you think about that? What are the kind of primary segments, subsegments you compartmentalize?
So when I think about neurotech, I guess it's any sort of technology that in some way interfaces with the brain. And then, of course, there's that buzzword interface. And how are we interfacing? Are we reading brain activity? Are we writing brain activity? I've listened to a lot of the episodes of the podcast, and I like hearing different people's takes. I can't remember who it was, somebody that thought, or they think about it very broadly, like even my phone in some way is some kind of neurotech or some kind of BCI or anything that, interfaces. I think a little bit more technically, I guess, like anything that falls in sort of the reading, writing space. When I teach this in teaching clinical neuroscience, for example, like I often bucket things into, and I realize there's more buckets, but kind of broadly, I talk about neuroimaging, neurostimulation or modulation, and BCIs. And I kind of look at these three things as being the three kind of biggest pieces of the sector. And that stimulation could be, cognitive like stimulation of the brain or peripheral stimulation that kind of still falls under neurotech for me, spinal cord stimulation, et cetera. And then the neuroimaging, and it's sort of the combination of those two things that makes up a lot of BCI space, is reading and writing. So we have a lot of reading, we have a lot of writing, and BCI is kind of reading and writing. I realize it's not always that, but and then I break down sort of under those and teach full courses on how each of those go out. So that's sort of how I tend to think about it. And I was going to mention one other thing actually when we were talking about at home and TMS stimulation, and it's kind of BCI kind of on the stimulation front. There's this amazing company called Motif, and they're developing sort of this take home stimulator device that allows you to. It is an implanted device, but it would be something that you could wear more permanently. And I think that was sort of a long-term vision that Dr. Williams had, was what he was calling iSaint, which is, so we had SAINT, was Stanford Accelerated Intelligent Neuromodulation Therapy, and iSaint being implanted SAINT, which is sort of like a device that could stimulate more permanently, almost like this pacemaker for the brain. And so maybe there's more of a solution in that way, but typically because of the required surgery, it's expected to be preserved for patients on the more severe end of depression or OCD or what have you. Because there are patients today who do get implanted DBS for OCD or something like the way we treat epilepsy.
Yeah, Motif's a nice example to lead into my next question. Is exactly where I wanted to go, Derrick, about a kind of almost a hybrid between BCI and TMS. So when you think about, I guess, the invasiveness continuum, DBS historically, but certainly BCI is in some case, major neurosurgery penetrating deep into the brain versus, we were talking about TMS, and Keith from Attune Neurosciences was earlier talking about focused ultrasound. There's various non-invasive neuromodulations. Do you see the ecosystem, the size of the market being big enough to kind of cater for all solutions? And it may be nothing simple, but the more severe the challenge, kind of the deeper you have to go, and maybe for less severe clinical challenges, we can go less invasive, as opposed to kind of there's a winner and a loser. BCI may win and TMS may lose. Do you see room for everything in the ecosystem?
Absolutely. I do not have any sort of scarcity mindset. I think everybody deserves the help that they can be offered. And the more tools we have, the better off we are. I think we should keep developing, keep innovating, continue to push more indications and more techniques to offer, because I think the farther we go, the more demand we'll actually see for additional techniques. And there's going to be new techniques we haven't even heard of yet. There's going to be new ways of interfacing with the brain. We already use electricity, magnets, sound. There's so many different healing protocols. And even within each of those spaces, the parameter space is massive. So I think we need more of that. We still don't have enough, and we're still just scratching the surface. So there's so much more to be done. The more we understand about different brain pathology using neuroimaging techniques. So I think, the neuroimaging and compute, it's amazing that there's neuroimaging data that's been collected over the last 10, 20, 40, 50 years, but we know we can do more with that data than we ever did before, because our compute is way better. And now we have new algorithms, new techniques, new ways of assessing all this stuff. And it's teaching us things that we didn't know that we could do, which then allows us to understand these pathologies better. And I think the reality is that we're going to get much better diagnostics. And one of my thesis is really around sort of N of one modeling, and how do we really focus on personalization, because each person's need is going to be a little bit different than the next. And I think there's going to be ways to personalize that are going to help people get better faster. And that's going to combine neuroimaging and different techniques in some kind of stratified way. And that depends on the data and how we're defining it. So take 10 different people with depression. All 10 of them could get different treatments. You could have 100 people with depression, and 100 of them might get slightly different treatments. And I'm sure we're going to find that certain techniques are going to maybe overall work a little bit better. And, I do think there's a tough hill for some other techniques to climb, because when it comes to depression, like we have a winner, so to speak, just on efficacy. We know how well TMS works. But I think once you identify the correct parameters and protocols for each person, there's going to be a sort of a protocol for everybody. And that's the psychiatry 3.0 vision that I focus on, and this idea of the future of psychiatry that combines all of those things. It combines computational psychiatry, looking at this algorithmic approach and how to find the right intervention for each person.
Yeah, I'll link to Mariam in episode 4. We dove pretty deep into AI psychiatry, the future potential user experience in that area. Definitely concur with your scarcity comment. I mean, even if you accept the number of 1 to 1.5 billion people with air quotes problems of the brain that need to be fixed, a ginormous market with a very significant unmet need, then the potential of the brain is anyone. So again, a slight cliche, potentially addressable market for all of us is 8 billion brains, not even a few 100 million or a billion. Which takes me like final question, Derrick. BCI so topical. I humbly studied economics, not neuroscience at university. I believe in the efficient market hypothesis broadly, that over time the market gets it right. There's always blips and bubbles, and in the short term it bounces around. But if you look at the flows of capital into Neurotech, BCI is taking the lion's share. And literally every week I seem to be reading about 100 billion plus seed check for another interpretation or application of BCI. So if the market's right, there may be an Elon Musk Neuralink effect in there as well, but the market seems to be saying our big bet in Neurotech is BCI, however you define it. Do you think that's a rational bet, or is there something else afoot with the flood of money we're seeing coming into BCI at the moment?
Yeah, it's a great question as well. I've thought a lot about this. I don't know that I have any right answer. And I think that goes for everything I've said in the last 40 minutes is like, I don't know that any of my answers are totally correct. That's just kind of the best of my knowledge and the things that I've learned. But the way I think about BCIs, and I've wondered a lot why, like when OpenAI decided to have this kind of spin-off and start their own BCI. It's curious to me that there's the space market, the BCI market, and like everybody's kind of, maybe they're just doing I don't know if you've ever heard like the McDonald's Burger King analogy of how they made decisions. Like, back in the day when McDonald's, they were always kind of had more money than Burger King. So they would do all this market research to decide where to open up a franchise and where to place a store, where they're going to have sales. Burger King didn't have that money, so they would just open a Burger King close enough to McDonald's, because they're like, great, you did the research, so we'll go. And I'm like, so I wonder is like, okay, now you have all these other billionaires like, great, well, we know there's a market for space. So Elon proved that market, so now we're going to go do that. Oh, he proved there's this BCI market, or even though, nobody's really making money there yet. So maybe they're just kind of following and saying, great, we'll do that. I think maybe the sneaky play there is just the extremely long term, that they realize that BCI as compute increases and this sort of hybrid cyborg type lifestyle is maybe going to just become more real 10 years from now. Like our world today, as it was 20 years ago, is extremely different. I mean, the day to day might feel a lot the same, but if you really look at it, so much has changed. I don't go a day without spending a significant proportion of time on some device and interfacing with that. And the idea that you could maybe interface with that device at extremely high fidelity using a brain computer interface. Like, I think in that sense, the reason people sell phones, like why big, phone companies and computer companies are some of the largest companies, Google and Apple and so on, is because they find something that every single person on the planet wants to have. And when you can sell something for anybody, then that's a massive market. And so something like a brain-computer interface, I feel like the people running those companies really have that mindset. They're like, yeah, we're going to go after those 8 billion people. And it's unlikely that we're going to have 8 billion people with chips anytime soon. But if you think 50 years from now, there might be a really large number of people getting that done, and maybe it just becomes normal. And so maybe that's what they're thinking. I'm not saying whether or not I love that or agree with it. I just, maybe that's why they're pushing in that direction. And I think they've seen the use case, and that it is a bit of a holy grail, and that if you can solve that BCI problem, like right now you're doing one chip. What if you had 12 chips across all different brain regions, and you could really restore vision and restore movement, and you could solve for depression because that same chip, all you have to do is figure out the read and write patterns, and then you could solve for OCD. It's possible that kind of just does both. It does all the best things of both worlds, and they haven't solved for all of that yet. But again, if you're looking on long term, it's likely that they could. And a single BCI could maybe take everything we learned from doing 40 years of TMS research and then just train that chip to do what it needs to do for TMS or electrical or what have you. And so maybe that's where that goes. But I am still seeing a lot more money coming into focus ultrasound, TMS. And I think that the market is overall shifting from just focusing on one thing. As neurotech becomes a hotter market, there's going to be larger companies building these new sectors, I think, on new, or maybe not new technology, but, existing technology that's outside of BCI. Like, I think we'll see some of these billion-dollar brain stimulation companies, and as we kind of start to steal and get more market share and reach the actual large number of people who need it. Right now, TMS services less than 1% of people who actually need TMS. If we were servicing 100% of people that need it, that becomes a many, many billion-dollar market.
Sure. A great summary, Derrick, on BCI. I guess we seem to have surpassed Star Trek already in many ways. It sounds like you're alluding to a Terminator future there.
I hope not.
I'm not sure if it's utopian or dystopian, but yeah, look, we're heading in an interesting direction, to say the least. And maybe my grandkids will learn 6 languages a lot quicker than I'm currently learning French on Duolingo.
Yeah, I'd be curious to see what kind of other learning opportunities are out there, and how well that the read and write can get. Could we write in new languages? It's an exciting proposition.
Exactly. Look, could talk for hours, Derrick, but I want to be respectful of your time. Thank you so much for joining the Business of Neurotech podcasts. I'm really keen to jam a lot of links into the show notes. You got so much depth of knowledge in many of these areas, but headlines, where do you want to send people that want to follow what you're writing about online?
Thanks. Yeah, I have a lot of different socials, but the easiest place to find me that connects to all my socials is just my website right here, DerrickBuchanan.com. And then from there, you can find anything related to the companies I'm working with. Some of the stuff I'm doing right now is not super public yet, but feel free, if you're interested, you can always reach out to me. And I'm talking about these things, but we don't have a huge public facing presence yet. But whether you're listening to this episode now or maybe years from now, as this podcast lives on, go to my website there, DerrickBuchanan.com, and it'll be up to date with all the things that I am doing, places where you can see me speak and connect to my other socials, YouTube, Instagram, etc.
Great stuff. Derrick, thank you so much for joining the Business of Neurotech podcast.
Thank you, Adam. Really great to be here, and thanks for having me.
Thanks for listening to the show. For more information on the podcast, individual show notes, and all the links about where you can find the show, please visit businessofneurotech.com. We look forward to seeing you on a future episode.